This is something about firearms and how how the calibers work. Basically, caliber is supposed to be the diameter of the round. Unfortunately, there's a lot of trouble with it. First of all, how do you figure out the diameter? We have here a couple of different diagrams. It's supposed to be a smooth bore, a traditionally rifled bore, and a polygonal bore. And this would be a traditional rifle. I don't know how well you can see that, but basically it looks like a series of spiral helixes going down. That's created by carving grooves and leaving lands going down in a spiral pattern down the length of the barrel. Then you have them where they are created by cutting these polygons in a spiraling fashion down the length of a barrel. This is used in a Glock. Now these can go right hand, left hand, or clockwise, counterclockwise. I don't accept anti-clockwise because that indicates that there is no pattern whatsoever, if you think about it. And usually goes in one turn in blank length. One turn in 7 inches, one turn in 9 inches, or 1 in 7 twist, 1 in 9 twist. But the problem we run into is this means you have 3 separate measurements you can do to figure out caliber. This one, from groove to groove. This one, the diameter from land to land. And there's also bullet diameter, which leads to some interesting figures. Over here, the 380 automatic Colt pistol is 0.355 inches in diameter. The same diameter as 9mm Luger, 0.355 inches, and 357 SIG, 0.355 inches. How do I know this? Well, I got it right from the book. And trust me, this is not the book you want thrown at you. But 9mm Makarov, or 9x18, is 0.364 thousandths of an inch. So Soviet 9mm is not the same as American 9mm or European 9mm. But 38 Special is 0.358 or 0.357 inches, depending on what kind of round you're using. The same diameter as 357 Magnum. Now, remember the difference between Soviet and Western 9mm? 7.62 NATO is 0.308 inches, whereas 7.62 by 39 Soviet is 0.31 inches in diameter. These are bullet diameters. Why is this so? Well, like I said, land diameter versus groove diameter. What we have going on is, in order for the bullet to fully engage the rifling, has to be just a little bit thicker than the land-to-land diameter. That one. And the end result is you get these grooves pressed into the side of a round. The 5.56 round that I recovered, I don't know how well you can see it, but there are these longitudinal, spinning longitudinal, pressed forms into the side of the round. Looks something like this. But that means it's engaging there and spinning, so what happens is the round, as it goes down the barrel, it's perfectly, or in theory, it's perfectly symmetrical around itself. So by putting a longitudinal spin on it as it's traveling forward, it keeps itself stabilized, therefore going further, straighter, faster, and doesn't just go all sorts of erratic wonky and then take a left turn at Albuquerque. 2 points if you got the reference. So this is why we have these different numbers. Now, the other way we figure out how we identify which rounds is a couple of different ones. Give me a... Okay, so a couple of different ways to name cartridges. There is caliber. Caliber is either in metric and millimeters, usually, sometimes in centimeters if we're talking about actual guns, not small arms, or we have them in thousandths of an inch. So, old school black powder method, you would do the caliber times the powder charge behind it. The best examples is the lineage of the Springfield trapdoor rifles. The first ones were 58-70, then they went down to 50 caliber, a half an inch, 70, and then they went down to 45-70. They used that until they changed over to 30 caliber smokeless powder, which created a couple of hybrid cartridges, or cartridge names. The 30-30 Winchester centerfire was originally started at the very start as a black powder. However, by the time it got released by Winchester into the general market, it was a smokeless powder. That's what. But they did 30 Winchester centerfire, but it also became known as 30-30 because it was a 30 caliber round being powered by what was the equivalent of 30 grains of black powder. Grain is the imperial measurement for weight for very small amounts, and it's often used almost exclusively by firearms. We talk about weight of bullets in grains and imperial measurements, and we also talk about measurements of powder in grains in imperial measurements. Now, the other way of doing these is the named cartridges, where they will do a caliber and a name after it. So for instance, 308 Winchester, that is a specification. 38 Super, that is a specific cartridge. 300 Blackout, that is a specific cartridge. 10mm Auto, that is a specific cartridge. Now, the Europeans will also do by naming. 5.7 by 28, 7.62 by 39, 7.62 by 51. these are usually given in millimeters. Not necessarily specific, but rounded up or rounded down. So 5.7 by 28. I don't know the actual diameter on a 5.7, but I'm sure there are a few more spaces there of measurements. 7.62, again, not exactly, but that's what they're using. That's the common term, 762 by 39 or 762 Soviet. Now, how can you tell what kind of firearm you have? Well, this one right up here, where my thumbnail is going over it, says 10 Mike Alpha Uniform Tango Oscar. 10 Mike Alpha Uniform Tango Oscar. Literally says 10 millimeter auto on there. This one, I don't know how well you can see it, .45 space Alpha Charlie Papa. 45 ACP right on the top. You'll often find these on a lot of barrels and stuff, and that will actually let you know which round to use. So just look for what the caliber designation is. Now the problem you run into is the Europeans started using this a lot earlier, and they also took their bore diameter measurements a little bit different than the Americans. So 30-06 in German was something like 7.5 by, what was the diameter, or what was the length? 7.5 by 63. But yeah. Why? Well, when they calculate it, that's how they figured it out. Now, because of NATO and everything else, we've kind of redone this. But again, like I said, there are different naming conventions. However, best bet is to actually look on said firearm and look on the barrel or on the receiver somewhere. It should say what kind of round it's set up for. And the thing is, with AR-15 type rifles, because you can rebuild them and rebarrel them, you need to check the barrel. In fact, let me show you what I'm talking about. This is pretty much impossible for you to see, but 300 Alpha Alpha Charlie Bravo Lima Kilo 1:7 300 blackout, that 300 AAC blackout, 1 in 7 twist. Just to prove that nothing is wrong and no shenanigans. Empty rifle. And keep bad things from happening, we have right there 300 blackout. All right. I know I've mentioned this before, but bears again. All right. On the back of the round, bullet, case, primer, powder charge inside, they will have, commercial rounds will have the designator, 5.7 by 28, stamped on there. Let's take a look at a commercial here. 9mm Luger. So this is one set up for 9mm Luger or 9 by 19. And here we go. Winchester .308 Win. Here we have Winchester made, 270 Winchester. Now, where it gets funky is in military rounds. This is a mil spec 5.56. They'll put different codes on there. This one has manufacturing code FC, made in 2008. So, and the Winchester NATO, or Winchester versus NATO, I've already talked about. NATO will have year of manufacture, the production code, or the manufacturer's code, WCC 2014, and the little star, or the little cross in the circle. But if you look on the box that it's sold, it will tell you which caliber it's set up for. And generally speaking, the firearm will still have said caliber on there. But if you don't know what you're looking at, don't just go around throwing random rounds into a firearm until you find one that actually fits. That's not going to end well, trust me. Because, believe it or not, your 300 Blackout will chamber in a barrel set up for 5.56 by 45. But the problem you run into is this is 7.62 in diameter, that's 5.56, and you'll blow up the rifle barrel because that will get jammed into the barrel and create so much drag and friction it's going to stop, and you're still going to have that massive pressure load behind it from all the burning gas, and it will blow up your receiver and barrel. So keep that in mind and actually look at what you're doing and make sure you're doing the right thing. Alright, bye.